Okay, so the second type of problem we're going to deal with is multiplication, which is really not that different from simplification. Now you have two numerators and two denominators, but we're just, again, going to factor anything, and then all the factors of the numerator will get multiplied together, and all the factors of the denominator will get multiplied together. So x plus 1 here and here, those are already factored, but we do need to factor this one and this denominator. All right, so the first one we have x plus 1, and I like to just put parentheses around any binomial that I see, just to keep it clean. And then we have 18x minus 63. Well, 9 goes into both 18 and 63, so I have a GCF of 9. So I'm going to take that out, and that leaves me with 9 times 2x gives me 18x, so 2x minus, and 9 times 7 gives me 63. All right, that's being multiplied by my second fraction, which has x plus 1 in the denominator. In the numerator, I see I have an x in both terms, so I'm going to be pulling out an x, but I also see I have a 10 and a 35, and 5 goes into both of those. So I'm going to pull out, instead of just x, I'm going to pull out 5x. Again, that is my GCF. All right, so 5x times 2x gives me 10x squared. And again, you get kind of a clue by looking at the factor that you've already discovered. A lot of times you're going to have common factors, so that's always something to try. So let's see, does 5x times negative 7 give me my negative 35x? And it does, in fact. So this is also a negative 7, 2x minus 7. All right, so when we're multiplying fractions, we just multiply the numerator. So x plus 1 times 5x times 2x minus 7. And we multiply the denominators. So 9x times 2x minus 7 times x plus 1. All right, so now we have one fraction with a bunch of factors. Next step, look for anything that will cancel. So my 2x minus 7 cancels, and also my x plus 1 cancels. So what does that leave me with? I have a 5x, and I have a 9. So that is 5x. Uh-oh, my pen is running out, so I'm going to switch here real quick. That is a 5x over 9 is my final simplified answer. But I do still need to do the domain restrictions. So I'm going to look in the denominator. That always gives me the domain restrictions. Now, I have three factors, 9, 2x minus 7, and x plus 1. I have to set them all not equal to 0. But if I say 9 not equal to 0, that's just always true. There's nothing to solve for. There's no variable. So I don't need to do anything with that. Okay? I do have a 2x minus 7 not equal to 0. If I add 7, I get 2x not equal to 0. And then if I divide by 2, I get x not equal, oops, that should have been, I'm so sorry, 2x not equal to 7. Getting ahead of myself there. Okay, because I added 7 to both sides. So this one goes away, and I get a positive 7 over here. Then when I divide 2, I've got x not equal to 7 over 2. So that's one answer for my domain restriction. My other one that I have is x plus 1 from right here, not equal to 0. Well, there I just need to subtract 1, so I get x not equal to negative 1. So x, my two domain restrictions are x not equal to negative 1 and positive 7 over 2.